Let's take a look now at question 6.6 from our textbook. And we're told in these following cases, we're given some data rather, to determine whether or not our reaction will favor reactants or products. So let's take a look at case A here. And the only information we're given is that delta G is positive. So previously, we looked at how when delta G was negative, we say that our reaction is spontaneous in the forward direction. So that would favor products. So in this case, with a positive delta G, this would be reactant favored. So we'll write our final answer over here. So this is reactant favored. All right, so let's look at case B here. And KEQ is given as 0.5. So again, what is KEQ? Let's take a look. So that's a ratio of the concentration at equilibrium of products to reactants. So if we had more product than reactant, we would have a KEQ that is greater than 1. But in this case, our KEQ is less than 1. So that means that we would again have a reactant favored reaction here. All right, so for our next case, case C, we are given a temperature, we're given a delta H, and we're given a delta S. So we know that delta G, the delta G equation can be determined, or rather the sign of delta G can be determined from our change in enthalpy minus our change in entropy. So we're given a positive enthalpy change, but then a negative entropy times temperature would result here if we plug in a positive delta S. So we have competing terms, but we could actually plug in these values. So if we did that, we would see that we have 33 minus 298 times 0.150 kilojoules, right? We want both of these in kilojoules per mole, Kelvin in this case. So if we multiply 298 by 0.150 and subtract that from 33, our final answer would give us a delta G of negative 11.7 kilojoules per mole. So this is our final delta G here. And we know that with a negative delta G, that would favor products. So this is our first case. That is product favored. So products. For C, let's look at our next example here. We have an exothermic reaction that just is told to have a positive delta S for the system. So both of these terms would contribute to a negative delta G. So let's write this over here. So delta G, we have exothermic, so negative, minus T times some positive value here. So negative minus some more. So overall, we would definitely have a negative delta G. And we know that this is spontaneous in the forward direction. So this would also be a product favored reaction. And in our last scenario here, we see an endothermic reaction. So our delta G would be positive, so for our enthalpy change, minus some at some temperature times a positive value. Oh, I'm sorry, a negative value now for our entropy change. So we have positive minus a negative value. So both of these will contribute towards a positive delta G. And we would say that our reaction is spontaneous in the reverse direction, right? Or non-spontaneous in the forward direction. And since we're looking for either reactant or product favored, if it's spontaneous in the reverse, we would say that this reaction favors reactants. So we have a few different cases here, and we discussed different reasons for why these reactions would either be reactant favored or product favored, given the information here. So we'll look at problem 6.7 next time.